So that's the primary. You want to make sure you're in degrees, but the answers will be in radians. So you have to remember how to convert from degree to radian. And to do that, you multiply by pi over 180. Pi over 180. Okay, so 30 times pi over 180 is 30 pi over 180, which is pi over 6, like that. And that would be the answer, the full answer you would see here.
Okay.
That'd be it. So then, I mean, there's a bunch here to look at. So why don't you go to your calculator and do the cosine inverse, the arc cosine inverse of 1/2. Make sure your mode is in degrees and tell me what you come up with.
Pi over 3.
So you got 60 degrees, you multiply by pi over 180, and you get pi over 3. And the same thing works with any of these other like more sophisticated ones. Your calculator should have an arc tangent of that. So if you want to grab your calculator again and do the same thing.
Pi over 6.
So you're getting the hang of this. Now, the only thing you might not know how to do is something like what's in 12, which is arc cotangent. So because cotangent is 1 over tangent, the way you would do this is you would do 1 over the tan inverse of minus square root of 3. So you've got arc secant, which is weird because you probably don't get that very often, but it would be 1 over the cosine inverse of x, and then the arc cosecant is 1 over the sine inverse of x, like that. So if you get one of those, your calculator won't have a secant, arc cosecant, arc cotangent. You'll have to do the reciprocal stuff of it. Any questions on that?
Nope.
All right. So we should move to 19, 20, and 21.
Okay.
All right, so we'll get to the actual questions here. The first question, 19, is to find the cosine of y, which so that the cosine of y you can do without any sort of work here. Cosine is adjacent over hypotenuse. Do you need do you still have the trig cheat sheet, or do you want me to send that over to you again?
Oh, I have it.
Okay. So the adjacent here is x over the hypotenuse is 1. So your answer here is cosine y equals just x. Okay, which I didn't, I mean, I was thinking that they were going to ask you to do something with the other sides of the triangle. That comes in part, or number 20 here. So number 20 is the sine of y. Sine of y is the opposite over the hypotenuse. Well, you don't have that. So what is it? Well, use the Pythagorean theorem to solve. And if you haven't done this in a while, okay, to solve for this missing side, you say, okay, it's x squared plus a is really x plus b squared equals 1 squared. So you have x squared plus b squared equals 1, and you're solving for b. You're solving for this other leg here. Okay, so you have b squared equals 1 minus x squared, And then to solve for b, you take the square root of both sides. B equals the square root 1 minus x squared, like that. So it's not like problems where you get a number, you get an expression for the side. So this is the square root of 1 minus x squared over 1, like that. So the sine of y is just square root of 1 minus x squared, like that. And then 21 is the tangent of y, which is opposite over adjacent. It's the square root of 1 minus x squared. And then the adjacent here is x. So all over x, like that. All right, let me just step away for 10 seconds, but I will be right back.
Okay.
Okay, I am back here. So typically though, you have to make the triangle, which is what's coming up in the next grouping of questions. So I guess we'll start with 29. Why not?
That's fine.
Why not? Yeah. So it's like, what do you even start with here? Okay, well, like you ignore this cosine, you just ignore it for the moment. So you set arc sine of 2x equal to theta. Okay, theta is the angle. So you have a right triangle here, and this is always theta. I mean, you can make it the other one up here at the top, but most students just make it that theta there. Now, do you remember how to undo arc sine?
No.
Okay, so we'll show it one time here. You take the sine of both sides. Okay,
Oh,
so
right. Okay. Yeah. I do
the
remember.
sine of 2x, I'm sorry, that's not the sine of 2x. 2x, because it undoes it, 2x equals sine
Of theta.
theta.
Yep.
So now if I'm going to switch the sides here, sine theta equals 2x. Sine is opposite over hypotenuse, but we don't have a bottom, so you typically have to put 1 there on the bottom. So it's 2x over 1. And then you almost always solve for the third side. Like it wouldn't make sense for them to give you a problem where you didn't need the third side. But I suppose it's possible you wouldn't need it. But I would just always solve for that missing third side there. Okay, so again, you want to go, it's a squared plus 2x squared equals 1 squared. A squared plus 4x squared equals 1. A squared equals 1 minus 4x squared, and then you take a square root of both sides. So a equals the square root of 1 minus 4x squared. So no calculus, just finding that missing side there. So square root of 1 minus 4x squared. There typically is always a square root involved in these.
Okay.
Okay, so that's great. Now you go back to the original. And kind of didn't like give you a full explanation, but what we really did is we made this part right here arc sine of 2x theta. So now you want the cosine of theta. The cosine of theta is the adjacent over the hypotenuse. So I'll do a couple more here to just sort of illustrate this. I'll do 30 next. It'll be a little more. This is the final answer, by the way. Sorry.
Okay.
So the final answer is like this equals square root 1 minus 4x squared. All right, so let me try to do this a little more formally. So you're really making a substitution. You're saying let theta equal arc tangent of 6x. So really you're finding the secant of theta. That's what you're really doing. Okay, but we don't know anything about it. So so we've got this triangle here. There's theta, but we know that theta equals the arctangent of 6x. So we have to undo arctangent by taking the tangent of both sides. So this becomes tangent theta equals 6x. Okay, so tangent is opposite over adjacent. So 6x over 1 like that. So would you solve for the missing hypotenuse here for
Yeah.
us, please?
So we would just solve it like normal, like a squared plus b squared equals c squared for the hypotenuse, right? So wouldn't it just be 6x squared plus 1? Well, 1 squared, but it's just 1.
Okay, that's c squared. I mean, like you said, it's
Yeah.
a squared plus b squared equals c squared, and you know this. So yeah, I mean, carry it all the way through. I mean, you do want it to be simplified as much as you can.
So isn't it 6x squared plus 1? Or
That's c squared. You want c. You want the
oh, right.
and you should square this. Like the answer probably will be reduced.
Okay. So it'd be the square root of 36x squared plus 1.
And sometimes they put the number first. I mean, it really just depends on what they're doing.
Okay.
Yeah, so that's great. So now you're trying to find the secant of theta. So all this stuff on the right is the build up to get the triangle. Secant of theta is 1 over the cosine of theta. So if you can figure out the cosine of theta, you then flip it. So cosine of theta is the adjacent over the hypotenuse. It'd be 1 over this. So the secant is the flip of that. So so let me just make this more clear. So cosine of theta is adjacent over hypotenuse, which is 1 over the square root of 1 plus 36x squared. And then secant is the flip of that. So square root of 1 plus 36x squared over 1, like that.
So then wouldn't it just flip back because it's one over that?
Cosine is 1 over, and so
Right.
secant is the flip.
The-
Like this
yeah,
is
the
your
opposite.
answer. This is
Okay,
your
yeah, yeah,
final answer.
yeah. Okay.
Yeah, so we should do a couple more of these. I mean, the the challenge is getting the triangle and then remembering, all your trig stuff.
Right.
So let's actually do 33 here. Okay, so again, you always start with a substitution. You say, okay, let theta equal arc secant of x over 3. So you're really finding the tangent of theta when you're all done. The so now that's just the setup. And so now we undo arc secant with secant. So you're gonna take the secant of theta, secant of arc secant of x over 3. And so secant of theta equals x over 3. So when you draw your triangle, there's theta again, like you have to get these and the x and the 3 in the right spot. And that's really the challenge. The challenge is like uh, you know, what what goes where. So again, like secant is the reciprocal of cosine. Okay, so the cosine is the flip of this. I feel like that was unclear in the last problem. Like secant is this, which means that cosine of theta is the flip of this.
Right.
And so that makes it easier because you know sine and cosine and tangent. Cosine is adjacent over hypotenuse 3 over x square root of the sense of being the square. Well, I'll let you actually solve for that. So could you solve for that missing side, please?
Yeah. The square root of x plus 3 times x minus 3 all over 3.
Again, it's a squared plus b squared equals c squared. Your a is 3, your c is x. It's not a difference of squares situation. I mean, I guess it could be, but it's the square root of. Okay, so a is 3, c is x, so we have 9 plus b squared equals x squared. So b squared equals x squared minus 9. You don't have to use the difference of squares. You just leave it as that because it doesn't like cancel out or anything. So this is
Oh,
like the
okay.
more square root of x squared minus 9. Okay, so tangent of theta, like we're back, like all this work on the right to get back to our original problem, which is tangent of theta is the opposite over the adjacent. So what would that become?
Square root of x squared minus 9 all over 3.
Good. Okay. So that is a good start. Why don't you try 32 on your own here? And we can decide if we want to do any more after this, but yeah, go ahead and try that and let me know if you have any questions along the way.
X over the square root of 1 plus x squared.
That is correct. All right, and some calculators will actually do this all for you, if if that was concern that I've had students just try to do it that way where they don't even want to do it by hand. It's not that bad. So why are we doing all that? I'm not sure, because I guess so. The next grouping question is 37 through 40. These are rarely covered in this course. Like, this seems really out of scope, but maybe skip that. Not sure. We could go to the derivative stuff next, which is the calculus stuff, or go to the, I guess you don't have any integrals, but what would
Fine, that's fine. We can skip that portion.
we get, I mean, what I'm saying is we can do it. I'm just asking because I don't
No, it's fine. That's fine. We can go to the next section.
Okay, so the next section is derivatives. So in your common derivative rules, there's a whole place for inverse trig functions, and a lot of students say, they ask, do I need to know all these? And the answer is, well, it depends on your instructor. It depends on what they want here. So one of the things that really isn't super clear, that really should be, is that it's really always a chain rule derivative. So sine inverse of u equals 1 over the square root 1 minus u squared u prime. So your u is whatever this is. Like, this is your u. Your u, it's a little deceptive when it's x, because you think, oh, it's just x. Well, it could be x minus 1, could be anything you want in here. So sometimes it's good to kind of go back to how we were doing derivatives with chain rule, and saying, okay, it's really f of x is really arc sine of u, and u equals x minus 1. So then when you take your derivative is 1 over square root 1 minus u squared times u prime. Well, what is u prime? It's the derivative of x, which is 1. And then you back substitute. So you put your u back in, you put your u prime back in. So it's 1 over the square root of 1 minus x minus 1 squared times 1, which doesn't account for anything. So your final answer here looks like this. Occasionally that they do expand this, but not always. So sometimes this is probably okay as is.
Okay.
All right, so we can do a couple more. Let's see here. All right, let's do look at 45. All right, so again, if you go to your reference sheet, you'll see that for arc tangent, again, like some of these you can sort of pattern. Like, you'll notice that arc cosine and arc sine are really similar, except for a minus sign. But arc tangent's totally different. There's no root, there's a plus, like, it's totally different. So that's where you gotta you really probably do have to memorize these or get them on a reference sheet. So again, like, you can really treat like this thing here like it's a u, and that's u, and then you're multiplying by u prime. So like, I would tell students to look at this as arctangent of u, and u is really e to the x. All right, so your derivative is 1 over 1 plus u squared times u prime, like that. And u prime is e to the x, because the derivative of e is itself. Is that okay?
Yep.
clear? So now the back substitution 1 plus e to the x squared times e to the x becomes e to the x on top. And then here you've got an exponent to an exponent, so you end up multiplying. It probably would look like this when you simplify. So why don't you try number 46 on your own? And I'll snip in the formula for it here for cotangent. And you'll see it's really similar to tangent. It's just got a negative. So just the difference, just that little negative there. All right, let's give that a try, please.
Negative 1/2x to the power of half times 1 plus x in parentheses.
Like that?
Yep.
That is correct. Good. Okay. All right, so we can move kind of past these into product, quotient rule. Maybe we haven't done maybe a quotient rule in a while. Is that the only one? We should do a quotient rule. So we'll do 47, and then maybe we'll do a main rule. All right, so so we haven't done this in a while. Like it's good to be okay. F is the top function, arc sine 3x, g is the bottom function. Could you give me the derivative of arc sine, please?
Uh, 3 over the square root of 1 minus 9x squared.
Very, very good. All right, so now it's about remembering the rule. So it's f prime g plus fg prime. Basically, you're always pairing, derivative with a non-derivative, or I'm sorry, non-derivative with a derivative, and so on. Order doesn't really matter, but it's going to be 1 times the arc sine of 3x plus 3x over the square root of 1 minus 9x squared, like that. Any questions on that?
Nope.
Okay. Let's look at 49 next. So this is a chain rule problem because there's an inside function there. So h of t is really sine of u, and u is really arc cosine t. So your derivative, if you're called a chain rule, it's take the derivative of the outside function. Derivative of sine is cosine. You keep the inside function, and then you multiply by the derivative of the inside function. So what is the derivative of arcsine?
-1 over the square root of 1 minus t squared.
Good. All right. Got it. So the h prime of t is cosine of u. U is really that arc cosine of t. U prime is -1 over the square root of 1 minus t squared, like that. And that's your final answer. Huh. Wonderful timing. All right, so let me give you or if you can, try 48 on your own. I need a moment to snip it in because my Google logs out at the most inappropriate times, worst times. All right, sign in.
Do you want me to solve this one?
Yes, sorry, I was asking. Yeah, sorry. There's a product rule problem. If you want to give
That's
that a
okay.
try, please.
Yeah. Five x squared plus 2x arc tangent 5x plus 5x to the third power arctangent.
Sorry, you're gonna have to start over. I didn't
Oh,
catch
you're
any of
good.
that.
It
Okay,
was
so
5x
5x
plus 2x arctangent 5x.
like this,
Yeah. And then plus 50x to the third arctangent 5x
like
all
this.
over, yeah, all over 25x squared plus 1.
Okay.
So the entire thing is over it.
The whole thing is over this.
Yeah.
Okay. I mean, none of the problems I did had, I mean, well, I'll just back up here. So I mean, okay, let me suggest, we'll just, I'll just work this out here because I want you to see that the way they're gonna expect you to do on the exam is not, and they're not expecting you to do some complex algebra. They're just expecting you to fit the pieces together. So G prime is, like you said, 1/1 plus 25x squared or 25x squared plus 1. So you're just pairing these up, like x squared times that. So x squared over 1 plus 25x squared plus product rule 2x arctangent of 5x. Now you could make a common denominator here, but it's pretty rare. And I guess I didn't say that um, um, uh, but this is, I'm pretty like, this is how it probably been. They're not going to make you multiply top and bottom by 1 plus 25x squared and then break it apart into two terms. It probably would look something closer to this.
Okay.
So the the ones we didn't do, 50 and 51. I mean, 50 is actually nothing. 51 is just more complicated. Do you we got some time. Do you have some new pictures? I know you sent us some pictures last week. Um, on Wednesday, or I don't know, last week maybe, but happy to go back, or there's a few more you want us to solve from.
No, I think that's pretty much it. This was basically just like review because like we had gone over this one and this is the last lecture and before the test because it's not like a cumulative final. It's just like a
Okay. That's
test.
just the next one. Okay.
Yeah, so I'm good. If that
Nothing else you have questions on before we close out?
Nope.
All right. Well, and you said you're not taking a math class this semester?
No.
Okay. All right. Well, let me go ahead and stop the recording here.